All right. So what we're going to do for our table, we're going to put this vertical asymptote into the middle of our table, and we're going to go a half in both directions, and then two more integers. So from -1, I'm going to subtract a half and get a -1.5. I'm going to add 1/2 and go to -0.5. Then I'm going to count two more integers in both directions. All right, so I'm going to graph that. So I'm over here, I'm going to write y equals 2x plus 1 over x plus 1. All right, we're going to get this graph, but we're going to do better than that. So I'm going to hit the cog, I'm going to hit the table, and I'm going to get rid of all these values they already have. I don't want these. We said we wanted -3, -2, -1.5, then I'm going to go -0.5, 0, and 1. These are the values that we're going to use. Let me double check. 2x plus 1 over x plus 1. Okay. So now what we're going to do, I'm not going to do it on the paper, you're going to do it. To start, let me do this real quick. I'm going to erase this. We are going to graph on your paper our vertical asymptote. X equals -1. You're going to draw this line. Then you're going to draw your horizontal asymptote. X equals 2. No, x equals 2. Make that y equals 2. So those are my vertical and horizontal asymptotes. Then we're going to come up here. We're going to plot the points and curve the lines. The lines need to start close, where I'm at my cursor, start close to your horizontal, hit these 3 points and go vertical without crossing the vertical asymptote. So I'm going to start down here, curve, and then towards it. We should not cross our asymptotes. So you're going to plot the 3 points on the left, 3 points on the right, start at this flat line, curve up to the vertical, start at the vertical, curve up towards the flat, and connect the dots. That is how we're going to graph these. So again, we're going to go a half on both sides of the vertical asymptote, then two more numbers. Those 6 points, 3 on each side of the verticals, is what we're going to graph. And we should look something like this on your paper. All right, so let's do another. All right. F of x equals x plus 1 over x squared minus 4. F of x equals x plus 1 over x squared minus 4. Pause this as much as you need to. I'm going to factor my denominator. So that tells me, going through this, my denominator not equal to 0 gives me my domain. X can't be a positive or -2. My denominator equal to 0 gives me my vertical asymptote, so I'm going to have 2. My larger exponent is on the bottom. So I'm going to say horizontal is y equals 0. Back here, they were the same. So I took the fraction y equals 2. This one, they're different. My end behavior, I'm going to do this as I'm setting this up. I have my graph. I'm going to graph my horizontal asymptote, which is here. I'm going to graph my vertical asymptotes that are here and here. As my graph curves, it's going to flatten out. I don't know if this is what it looks like. It probably looks something like this and maybe something like this. The idea is as I get away from the middle, my graph is getting close to that horizontal asymptote, so my end behavior is going to read as x approaches positive, negative infinity, y approaches my horizontal asymptote, which is 0. Let me do some erasing over here. Just erase all of it and start over. All right, x-intercept. To find my x-intercept, we set our numerator equal to 0. Because my fraction 0 over something, we can set all of it equal to 0 and solve, but we just set the numerator equal to 0. To find my y-intercept, I'm going to use this one because it's easier. I'm going to plug a 0 into x. We get negative 1/4. So, going through quick, my domain is my denominator not equal to 0. My vertical asymptote is my denominator equal to 0. My end behavior is as x approaches positive, negative infinity, y approaches my horizontal asymptote, which is 0. My numerator equal to 0 is my x-intercept. Plugging a 0 into x gives me my y-intercepts. All right, so let me redraw these asymptotes. Because I have two asymptotes, I'm going to end up with 3 pieces of a graph. I'm going to have something going on over here, something happening here, and something happening here. So what we're going to do, on the last one, I said we put our vertical asymptotes in and go each side. So I'm going to plug in negative 2 and a positive 2 where my graph doesn't exist. All right, my graph does not exist at those points. From each of my verticals, I'm going to go a half both ways. I want to go a half on both sides of those. And then a couple more integers. Negative 3, negative 4, positive 3, positive 4. Then I'm going to go negative 1, 0, and positive 1. So that's a bunch of numbers. Setting up the table is all we have to do because we're not going to do the math ourselves. We're going to let Desmos do it. All right, so I'm going to get away from here for a second. I'm going to get rid of these. I'm going to start with x equals 2, x equals a negative 2, and y equals 0. Those are my asymptotes. Then I'm going to go y equals x plus 1 over x squared minus 4. All right, if you look at this, it fits in there. But we're just not going to copy that. I want some good values. So I'm going to make, no, I'm going to get rid of that wrong thing. From here, I'm going to hit the cog. I'm going to make a table. All right, let me go back so I can see both at the same time. All right, so I'm going to type in negative 4, negative 3, negative 2.5, negative 1.5, negative 1, 0, 1, 1.5, 2.5, 3, and 4. Whole bunch of decimals. All right. I'm not going to expect you to write down all that decimal. We're going to write down 3 places. All right, so I'm going to start plugging in some numbers. This is going to be negative 0.25, negative 0.4, negative 0.666, 0.286, 0, negative 0.25, negative 0.667, negative 1.429, 1.556, 0.8, and 0.417. All right, like I said, we didn't do that math. We let the computer do it for us. So we can't complain about it being a lot because we're not doing it. All right, now I'm going to plot each of these points. I'm going to do them in 3 parts. So these Negative 4, negative 0.25. Negative 3, negative 0.4. Negative 2.5, right about there. Now I'm going to connect those, starting close and curving. Now I'm going to go to the middle. Get these points. All right, negative 1.5, 0.287, about there. Negative 1, 0, 0, negative 0.25. Negative 1, negative here, and about there. So now I'm going to connect these, starting and ending close to these verticals. Something like that. Then lastly, my third piece. 2.5, 1.556, 3.8, 4.4. And if I look at these two graphs, yeah, they look close enough. All right, so after we get all of this, if I double check it, my y-intercept, my x-intercept's negative 1, that's true. My y-intercept's at negative 0.25, that's true. And I got everything else that matches up. So when you make your table, both vertical asymptotes go into the graph but don't exist. We're going to go half from both sides. From negative 2 to negative 2.5 to negative 1.5. From 2 to 1.5 and 2.5. This gives us a good curve as we get close. That's why we do that. On a test, on a quiz, I'm going to expect to see all of this, your table and the graph. All right? It's not acceptable to just look at the graph and figure everything out. We need to understand where all these numbers are coming from. My domain, denominator not equal to 0. My vertical asymptote, my denominator equals 0. My horizontal is based on my largest exponent at the bottom. So that makes it y equals 0, which gives me my end behavior. X-intercept, you set your numerator equal to 0. Y-intercept, you plug a 0 into x. That's the whole concept for this lesson. We're not going to do another. That should be enough, because if we do another, it's going to be the same idea over and over again. All right, if you have any questions, please send me a message. Come to tutoring on Friday at 12:20. Do something. Do not come in here on Wednesday without having some idea of what's going on. You have too many options. You can Google it, YouTube, Khan Academy. Come to tutoring. Email me. Call a friend. Do something. Don't just say you couldn't get it. If you need help, let me know and have a great day.